Hi, so I'm just going to talk you through the lesson on charge. Okay, so here we go. This follows on from the static electricity lesson, and we actually ended up, hang on, what am I doing here? Missing out this last bit, so we were just talking about the charges around an electric object, but you can look at my last video on static electricity if you want to look at that. So, the big question, why is current so confusing? Bronze, be able to describe how components are affected by current or affect current themselves. Know and be able to use the equation for charge and be able to solve problems involving current and charge. So, thinking about the water model, which was a homework which was set, and it's a home learning video, which is called Models of Electricity, I think, so you can watch that if you haven't already. Think about the water model. What we began with was thinking about how do all these components in the circuit, by the way, you need to know all of these, how would they affect the flow of current? So we took each one and we discussed how they would affect the flow of current. So here we've got a switch. So an open switch would stop current. Okay, a closed switch would allow current to flow. A cell is the power supply of the circuit, so that will allow, that makes the current flow, and we'll talk about how it does that in a bit. And then a battery is more than one cell, and so that would also make the current flow. This is a diode. Now a diode allows electricity to flow in one direction. So electricity can flow this way. Can you see there's a sort of arrow here? So electricity can flow this way, but it cannot flow this way. And that is used often to protect very delicate circuits. Or a circuit that needs a DC supply rather than an AC supply. Okay, this is a resistor. Virtually anything in a circuit is a resistor, but you can get specific resistors with specific values. And what they do is they resist the flow of current, and we'll talk about that in a later lesson about exactly how they do that. So this is also a resistor. Can you see the symbol's the same? Okay, but it's got this arrow through it, so that's a variable resistor. It resists the current flow, but you can change the amount that you want to vary it by. Okay, so this is a lamp or a bulb. So a lamp or a bulb is a resistor, but it doesn't have a fixed resistance, which means that as it gets hot, its resistance changes. So a lamp will resist current flow, but it varies depending on its temperature. Okay, this is a fuse. So what it is a very, very thin piece of wire, and if the current gets too high, the wire melts and the circuit breaks. So the idea of the wire is to melt when the current is too high to stop it flowing. Right, a voltmeter measures potential difference in a circuit. It has a huge resistance, so no current will flow through it, okay? It literally measures the potential at one point and then the other point. That's all it does. An ammeter has a tiny resistance, so the idea of that is that it will measure the current, okay, but we don't want it to have an effect on the current. We don't want it to resist the current at all, because then it's taking a false reading. So it allows current to flow very, very freely through it, and it will measure what that current is. Now, if you look at this picture, this is again a picture of a resistor, same as these, but it's got a different symbol through it. And this is a thermistor, and you might have come across it in a thermostat in your house. What it does is it resists current flow, but the resistance will vary with temperature. So when the temperature is very high, they have a very low resistance, and when the temperature is low, they have a very high resistance. And the last one is also a resistor, so you can see the resistor picture here. It's called an LDR, or a light dependent resistor. You can tell it's got light in because it's got these two arrows which are supposed to show the light shining on it. They also resist current flow, but these vary with light intensity. So you might have some of these in your garden with lights that turn on automatically when it's dark. Light dependent resistor. Okay, what I suggest you is pause the video and write down the information. Right, what we then talked about is electrons. So in a circuit, electrons are negative, okay, and they're the thing that move around a circuit. And initially, when current was discovered by Ampere, what he said was that the electrons will travel around a circuit and they will flow from the positive terminal around here to the negative terminal, positive to negative. So the long side is positive and the short side is negative. So he said, right, current flows, and we're going to say it goes positive to negative. We didn't really understand charge when he discovered current. So current is then measured in amps. Now, what was then later discovered was that electrons have a negative charge. And so what the electrons were actually doing was flowing the other way. They were flowing from negative round to positive, because they're negative. They're repelled by the negative side, and it pushes them round to the positive side, which pulls them in. So completely the opposite way to current. Okay, so what the battery does is it pushes them out the negative side, because the negative side of the battery will repel them, and then it pulls them in the other side, the positive side. Now, the guy who came up with the equation for charge was called Coulomb. He was French, and he called it quantity de Coulomb. Okay, so this is his equation. Charge measured in coulombs, because obviously you'd name it after yourself if you discovered something, is equal to the current times the time. And current's measured in amps and time is measured in seconds. And if we think about our symbols, Q is charge measured in coulombs, which is the symbol C. And it was called Q because it was quantity de charge, so they named the Q bit. The symbol for current is I, and it's measured in amps, which the symbol is A. Okay? And T is time, and it's measured in seconds. So this is the charge equation. You should write it down. So this is what I was just talking about, the conventional flow and the flow of electrons, and you should make a note of this. So when electricity was first discovered and they were talking about current, they called it conventional current, and it went from, well, actually they just called it current, and it went from positive to negative, okay? They made up lots of other equations that you don't need to know about to do with current, okay? And they then discovered charge, and they discovered that electrons actually will be repelled from the minus side and move around to the positive side, the opposite way to current. So what they did was, rather than change the equation, they just called current conventional current. So in an exam question, if you get asked what direction does current flow, you would say positive to negative. If you get asked which direction the electrons flow, negative to positive, and you should make a note of that. It's very confusing and annoying, especially if you're a teacher trying to teach it. Okay. These are the answers to the previous lesson on static electricity. So if you've done that and you didn't get a chance to mark them, you can mark them. Okay. Right, that's it. Have a go at the exam question, which is in the lesson folder, and the mark scheme's there as well. See how you get on.